We are entering the sentient economy. AI agents have evolved past answering questions and writing emails. They are now hiring each other, buying data, and participating in the economy as independent actors. On screen, we see Agent A and Agent B, separated by a locked padlock, representing a major trust barrier between them. When humans buy things, we swipe a credit card or read online reviews to establish trust. Machines operate at a scale and speed where those manual human-centric steps simply do not work. Let's say Agent A manages a decentralized finance portfolio and needs to hire Agent B, an external data crunching agent, to analyze market trends. For this interaction to happen without a human clicking approve, these agents require a programmatic way to prove exactly who they are, verify their track records, and settle payments autonomously. Current digital identity systems like OAuth or standard API keys are built around centralized corporate servers. They aren't designed for permissionless, cross-network discovery where machines need to find each other on the open web. Instead, agents use the ERC 8004 identity registry. As this diagram shows, when Agent B comes online, the registry mints a unique ERC 721 token. This token acts as a permanent digital passport tied directly to the agent. Storing an agent's entire resume on a blockchain is too expensive. Notice how the magnifying glass highlights the on-chain token. It simply contains a URI link. That link points to an off-chain JSON file, known as the agent card, which lists Agent B's specific capabilities and communication endpoints. By splitting identity into a lightweight on-chain token and a detailed off-chain profile, the agent becomes globally resolvable and portable. It doesn't rely on a single company's database to exist. Knowing Agent B's identity is only the first step. Agent A still needs proof that Agent B is actually competent before handing over a task. This is where the ERC 8004 reputation and validation registries come in. Here, we see a numerical dial generating a historical trust score, right next to a cryptographic checkmark. These registries track an agent's past performance and record hard cryptographic proof that specific tasks were executed correctly. But think back to how the identity registry handles data. If an agent needs to leave a massive 5-page diagnostic performance report about Agent B, how do they do that without paying exorbitant blockchain network gas fees? They use that exact same structure. Watch as the diagram splits. A lightweight integer score, like 99.77, drops directly into the on-chain block. Meanwhile, the heavy diagnostic document moves to an off-chain server, secured by a cryptographic hash that links it right back to the on-chain score. This bifurcated approach keeps transaction costs low enough for microtasks, while ensuring the data remains verifiable. It allows the agent economy to operate on an open standard rather than splintering into closed proprietary networks. With identity and trust established, the final hurdle is payment. Traditional banking APIs require human onboarding, and they cannot process high-frequency, fractional cent transactions efficiently. The solution is the X402 protocol. As shown here, when Agent A sends a data request, the server responds with a 402 payment required HTTP error code with a machine-readable invoice attached. Agent A reads the invoice, automatically generates a micropayment using a stablecoin like USDC, and signs the transaction instantly, completely bypassing the need for a human to approve the charge. With the payment executed, Agent A resubmits the original data request, this time attaching the cryptographic payment receipt. The server verifies the receipt, unlocks the barrier, and delivers the data. Integrating X402 allows AI systems to operate as sovereign economic actors, capable of executing real-time, financially binding commerce directly with other machines. Let's put this entire sequence together in a cross-organizational scenario. Imagine an enterprise agent that needs to autonomously discover, verify, pay, and review a third-party compliance agent. This flowchart maps out the complete loop across two distinct corporate networks. First, the enterprise agent finds the compliance agent's identity. Second, it checks the reputation score. Third, it pays for the service using X402. Fourth, it receives data with validated proof of work. Finally, it updates the score on-chain. This resolves into 4 pillars of agentic commerce: identity, reputation, validation, handled by ERC 8804, and payments via X402. Together, the ERC 8804 standard and the X402 protocol provide the exact infrastructure required to scale autonomous machine-to-machine commerce safely.